Hello everyone, I'm Carla and I work as Business Development Manager at RatedPower. First, apologies if we confused some of you with the webinar schedule. We had some inconveniences with dealing with different time frames. But anyways, we are here now, so I'll be moderating this webinar today. But first, let me give you a few hints on why we're doing this and who is RatedPower, right? Our company, from the very beginning, has had the mission to accelerate the energy transition through technology. Our one-stop software, PVDesign, helps developers, EPCists, and solar players reduce LCOE of their utility-scale solar PV projects by optimizing the design and engineering workflows, enabling them to unravel the best configuration for the construction of a PV plant. In today's webinars, we'll dive deep on solar energy yield modeling. Over the next 45 minutes, we'll brief on energy modeling, how solar designers and engineers have estimated energy production on utility scale projects, or what are the obstacles that they have been encountering, how the future looks like, etc. Then we'll put hands on task comparing the arcane of energy yield tool results, in particular PVsyst with PVDesign energy yield model. And then we'll highlight some of the key benefits for developers, EPCists, and other solar players of embedded energy tools in its PV software stacks. Finally, we'll have a Q&A session. Feel free to drop us a comment on the chat box at any time, and we'll go over them at the end of the session, right? So first, to discuss this topic, we have here today with us 4 very special guests. Much more impressive than the Coachella lineup, right? First, we have Megan Parsons. She's Chief Engineering at Blue Ridge Energy. She has been using PVDesign for solar development in her capacity as developer and previously as an EPC consultant engineering. Megan has been involved in all phases of solar project development. Hello, Megan. Good to see you.
Hey, good morning, good afternoon.
Then we have Greg Rosen, a renewable energy and finance professional who over the last 22 years has developed or financed more than $400 million worth solar projects. Greg has played a key role in scaling several clean energy companies such as SunPower or Mosaic. Hey Greg, how are you doing?
Great, it's great to be here.
Great. Then we have Dave Williams, that has been involved with climate enterprises by connecting private capital and technology. His experience in climate change and resiliency, renewable energy development, and social entrepreneurship. Hi, Dave. We're so excited to have you here.
Hi, good morning. Thanks for having me.
Thank you. And last but not least, we have our colleague at RatedPower, Felix Perez, an industrial engineer specialized in software development applied to solar technologies. He has been the nexus between engineering and the software development team at RatedPower over the last 4 years, being responsible for the energy yield calculation model. Hello, Felix. We are so excited to have you here.
Thank you so much. It's a pleasure to be here.
Well, thank you all for being here, not only our guests, but also anyone watching this webinar. We have people from all over the world today, from the US through Germany, Colombia, or Spain. We hope you enjoy it. So let's go for it, right? Sorry. We're going to take a look first at the energy modeling landscape and outlook. And to start with, I would like to throw some open questions to the floor. Starting with, what's your opinion on how has the PV energy production been historically estimated? Has this changed through time? How is it done today? What's your take on that? I don't know if you, Dave, wanna start?
Sure. Yeah, I mean, I think in the past, it's a good question about like, how did we get here in terms of energy prediction modeling? And I think, you know, particularly in the US, we really relied on these historical predictions that have been focused on typical meteorological years. So we looked back, you know, at the time when PV was just getting out of its nascency at 30-year data sets and looking for the median to develop what was known as a typical meteorological year. And it's gotten significantly more rigorous. And I think because of that foundation, we were really looking for the number of kilowatt hours per year. And now we've moved to well, number of kilowatt hours per year and intra-annual variability. And that's shifted pretty dramatically to diurnal and weather predictions, as well as kind of spatial and spectral variability, and really this question between power and energy.
Nice. And now let's talk a bit more on the present, right? We know that there are many tools available out there to estimate the energy yield, like, I don't know, the well-known PVsyst, SAM, Plan Predict, or of course, PVDesign. How can these tools do it better? What are they missing that could be improved?
Well, yeah, I think, you know, and I'm happy to jump in here and love others' thoughts too. I think as we kind of, I was alluding to, is we're moving from typical meteorological years to really trying to better understand the performance, not just on a daily basis, but probably even sub-hourly basis. We're going to start to witness the actual value of these programs aren't just in the number of kilowatt hours. So the tools themselves are going to have to meet that. So it's kind of this rapid optimization with much more dynamic characteristics and constraints than what we saw in the past. So by that, like looking at more where the value is being created, but especially by larger utility scale programs, is going to be how it interacts with the grid. And I think really the kind of fundamentals of that will be the integration of battery storage, 3D modeling, bifacial analysis, new technologies analysis, and being able to rapidly optimize around that.
Megan, you have experience in that as well. What do you think that it can be improved as well?
Yeah, so just within and I agree, as we get more into integrating battery storage technology, looking at even going sub-hourly into minute by minute data would be most helpful as we move forward into the market. I think also as we're getting into more interesting terrain on projects I've worked with in the United States, it's getting a little bit more hilly. Being able to model the different terrain versus just having an entire field all angled in one direction is going to be most important.
Definitely. And what other challenges have you been encountering when estimating or modeling your solar PV plants? Megan, sorry.
So I think yeah, sure. So one of the biggest challenges we have is doing things quickly in the front end. So the more we can get an accurate energy yield analysis earlier in the development phase, we can get more confidence with what the project economics will yield, and we can move more quickly through the development process, having better discussions with our financing entities, our partners, and also having a better model in our pro forma. So I think that where I've found PVDesign be most useful is to moving that very accurate energy analysis much closer to the front end development.
Definitely. Greg, do you have some, I mean, I think that you can add that something as well in that regard, regarding on the economical aspect as well.
Sure. You know, one of the many things that I like about PVDesign is the ability to look at the equipment and the setup of the equipment, the configuration, as well as the output of the system. And particularly right now with all of the supply chain delays that are occurring, it's very convenient to be able to look at if you use one kind of mounting system, but that mounting system may be delayed 2 months or 3 months versus another kind, which maybe you're more certain about because it's being manufactured within that country, but maybe it provides a little less power output in that, in that configuration. It just really helps to think through the characterization of the risk, because as we all know, all these risks are really intertwined.
Definitely. Good. I don't want to stop there because I just want first to have here Felix present our tool. We're going to take a break on the debate. I'm going to pass him the mic right now. Wait, let me check.
Sure, thanks.
Yeah. Can I share with you? No.
Yeah. Okay.
So
now.
I would like him to talk about more on the software, on our software PVDesign, so that you can have an overview of the energy yield calculation model behind it and how simulation results compare to those that PVCs provide, right? So go ahead, Felix.
Thanks. So, right, we wanted to show you in the first place a bit of how the software works and how it helps you achieve this kind of integration in the early stage of the development process that Megan was talking about. We really believe that it's a great tool for that. And we also wanted to show you how the energy yield model PVDesign has compares to the industry standard today, which is PVsyst. The thing with PVDesign is that for every single simulation you run, you will get a full layout, you will get an electrical system design, you will get a bill of quantities calculation, and you will get the energy yield performance, right? So the difference with PVCs here is that you upload a site definition, which includes the polygons defining the areas of the PV plant. And then it's really simple to just define, I want to use this PV module, I want to use this particular mounting structure or tracker or whatever. You can define the pitch very easily. And then the thing is that it's really easy to change any of these parameters on the fly. Like you can just run a new simulation right away. You can compare different simulations and really get a very comprehensive analysis from the get-go. Trying out different options. So here we have, for example, 4 different designs using single axis tracker, a regular fixed structure, and an east-west fixed structure. And you can see just how easy it is to review them in a single software.
So Felix, hold on a second. For those who are here attending today that are not familiarized with, for example, other tools like PVsyst, in PVsyst, you need to start the whole process from scratch if you make a small change in the layout, right?
Yes, that's accurate. The thing is that usually you will have a team of engineers doing these studies, right? You may have an engineer who is specialized in drawing the layouts in AutoCAD, and you may have another engineer who is specialized in calculating the energy yield, right? And just the fact that they are 2 different persons usually means that if you want to change something, like say you want to change the pitch, or if you are more drastic, if you want to change the mounting structure, that's going to require a huge amount of work. First to recalculate the layout, and then to run again the PVCS calculations, right? With PVDesign, having everything integrated at once allows for that analysis to be much more agile, and really also it's a matter of accuracy as well, because you will not make the mistake of, say, misconfiguring PVsyst, right? Imagine that you set up the shade scene in a way which is not perfect, or you not replicate the DC field precisely right. With PVDesign, because the entire software runs the calculation all at once, right? We calculate the layout and we pass on that information to the energy yield model within the same simulation. So the simulation is run every single time according to the layout, right? And there are no like mismatched configurations or the kind of human errors that arise when you do many things at once, right?
Gotcha. And
yeah.
No, go ahead.
And yeah, so the other thing I wanted to mention is that when we run these PVDesign simulations, we also can include the possibility of calculating the economical analysis as well. So you can do that really easily. You have templates which you can use to calculate the prices. And the thing is that when you incorporate this information into the simulation, now you're not only looking at layout and energy yield from an engineering standpoint, so megawatts peak in the PV plant, performance ratio and specific production, but you can also start looking at LCOE and the economic performance of the site. So it kind of ties together really nicely.
And this is, yeah, go ahead.
Hi, Carla. I was just going to ask Felix, so kind of what Greg had mentioned before. Can you speak to how the tool does analysis on bifacial panels?
Sure. So these simulations we run here, they were all using bifacial panels. We developed, so the entire energy yield calculation model of PVDesign was developed internally. And so we have full control of the source code and the methodologies. And for the Biofacial modules, we implemented a view factor model, which was developed by Enrel, I believe. And it's very similar to the one PVsyst uses. There are some minor differences. All of it is detailed in a very comprehensive methodology document we have published. You can download it in RatedPower.com, or also Emilio can maybe share it in the chat so you can get access to it. You have all the equations and references there, so it's really, really useful for that.
Excellent. Thank you.
Felix, you run some simulations comparing like you PVsyst projects and results and PVDesign, right?
Yeah. So we wanted to show you that. So one of the main questions that comes up when someone uses PVDesign is how does it compare to PVsyst, right? What are the results like? Do the results match? And so in the first place, we did a report in collaboration with Black & Veatch, where Black & Veatch reviewed our algorithms. They ran simulations in 4 different countries using different system configurations. And yeah, they found that the results are really, really similar. I encourage everyone who wants to know more about that to download that report. You can find it in RatedPower.com. And also the report is really interesting because when you're comparing the two softwares, you need to make sure that the comparison is it's well matched, right? And it's well made in the sense that you need to use of course, the same meteorological data, the same PAN and OND files for the results to match. But also, when you set up the configuration in PVsyst, it's really useful to understand what is the equivalent configuration between PVDesign and PVsyst, so that you can understand better how PVDesign works. So for example, you need to use a flat scene for the shading, right? And you need to use according to module strings, the according to module strings option in that dialog. And also, well, you need to set up backtracking when setting up the tracker. All of those little tweaks in the configuration, it's useful to understand how the two softwares compare, right? And well, for these designs, well, I wanted to thank Hassan. He's one of my colleagues. He ran the simulations. It's really interesting to compare the two options here. In PVDesign, we have a table which is fairly equivalent to the loss diagram in PVsyst. And well, the kind of analysis we do to compare the two is we go loss by loss and have a look at if the values match, right? So you can see here that in terms of the front face irradiance, we have a very close value. It is all the back face irradiance is very close as well. Here there are some differences in reporting, in that the losses we give are kind of different, especially this view factor for the rear side aspect. It's more or less this part here, the effect of ground shades. But then we also separate the effect of the near shading. So this includes, for example, the torque beam trackers and also the adjacent road. So it's a bit different. But at the end of the day, the results are very similar in terms of the kilowatt hours per square meter. And then looking into the electrical system, we also need to look at, for example, the temperature losses and irradiance level losses. So those are over here, right? These are matched pretty well between the two softwares because we use the same one diode model as PVCs, so it matches really well. And then in terms of the inverter, we also have a really good match usually. Mainly the points to look at here are the inverter output power limit. This is usually something where there will be a difference. For example, depending on the particular setup you used in PVDesign and in PVsyst, PVDesign can actually change the TCAC ratio of individual power stations to meet your requirements in terms of specific capacity and maximum capacity. So you may have, say, 50 power stations with DCAC ratio 1.2, and then a couple more power stations with DCAC ratio 1.25, for example. And then that can result in slight differences when it comes to simulating that in the energy yield model, right? And also the conversion efficiency loss, as you can see, it's very, very close. And so this simulation was in California, in this plant I was showing you earlier here. And we also ran another example in South Africa, which we find interesting because even though, so it's the same system using the same parameters in terms of a bifacial module, single axis tracker, but the meteorological data is completely different, right? And still the results are very similar. So we have pretty much the same values in terms of production, in terms of performance ratio. For example, here you can see that the irradiance in the front face and in the back face are pretty much the same again. And also it's interesting to look at, for example, this particular site. I think it's a bit colder than the California example. And so you see that the temperature loss is lower in this example. And it's lower in both PVsyst and pvDesign, right? So there is agreement in that regard. So yeah, again, anyone wanting to know more about how the two softwares compare, I really encourage you to read the Black and Beige reports. It's really great, and it really shows, it goes to a great level of detail regarding the algorithms and how you need to set up the two softwares to get an accurate comparison.
In this regard, Felix, how precise the yield analysis is compared to PVsyst, which is the precision?
Well, mostly it depends on the inputs, as usual. If you set up the same, so the accurate inputs in both, so same meteorological data and in that sense, good quality meteorological data, you will get very close results. Obviously, the simulations need to be equivalent. It doesn't make sense to compare a PVC simulation using 3D shading with pvDesign, because pvDesign, as of today, does the shading seen in a flat terrain. So you can compare the two really if you're doing 3D shading in PVCs, right? But other than that, I'd say it's really accurate as long as you have good meteorological data in the simulation.
Impressive. Thank you, Felix, for this well-explained comparative of the softwares.
Thanks.
Thank you very much for your insights. I don't know if go ahead.
Yeah, I had one final thing I wanted to show. We are really proud of the feature where you can compare different designs. So in this particular example, we did some examples where we changed the pitch, starting from a really close pitch distance to a really separate pitch distance using fixed structures. And so when I was speaking earlier about how powerful it is to have all of this in one single tool, just think that running this analysis is really simple with PVDesign. It takes only a few minutes. And if you include the economical analysis, so if you include your costs into the simulation, you can review the capex and you can review the LCOE of the designs and find the optimum. And here, as you can see, there is a trade-off between efficiency and the production, right? So we have a more production when the pitch is very, very close, but then as the year goes by and you get into winter, you start getting lower production because of shading losses, right? And with this tool, you can really make an in-depth analysis from the get-go regarding that part of the engineering process, which is usually very hard to do it so thoroughly as what you can do with pvDesign.
Interesting. Thanks for that, Felix. I was just watching some questions that they were throwing to us, and one of them was with regard to this this comparison tool. So that's nice. And
perfect. I'm going to pass you the sharing the screen there. Okay. I think you have it now.
Yeah, I have it.
Right.
Do you see my screen? Yeah.
Yep.
Great, perfect, thank you. So moving back to our discussion and to our special guests, Megan, Greg, Dave, I would like to, you have had a different experience using pvDesign, especially Megan, for example, for your own projects. Greg, Dave, you've issued a white paper on pvDesign energy yield based on your financial and consultancy background. So I would like to have an open discussion, and feel free to jump in whenever you want, with regard to the biggest benefits that you see in a tool like pvDesign that has an energy yield simulation tool embedded in a design software. I would like to start with, for example, Megan, that she has been working for a while already, more than 2 years with pvDesign.
Yeah, I think one thing that Felix touched on, but I'll emphasize that one of the benefits I've seen with pvDesign has been the transparency. So it's extremely important to be able to know what the assumptions are and to be able to communicate those to an independent engineer, your financing, your team, your engineering, group. And that's always been a challenge in the past when I've worked across different departments and different entities. So in addition to just the time savings from not having to jump between the different people, as Felix talked about, also the outputs and the reporting, showing the energy calculations, clearly showing the inputs and assumptions clear through the entire stack from design, equipment selection to the energy yield is extremely beneficial. And it's been helpful for me and many times to sit down with a large group and catch where we think we might have an error in our assumptions or have an opportunity to optimize.
Nice. Dave, Greg, when you were running and when you were analyzing the software and our energy model, I would like to have your opinion on that, and what's your take so far?
Sure, I'll jump in, Greg, and correct me where you might disagree. Like, I think the piece that's the most beneficial here is the agility. So like what Felix was just showing, that ability to compare projects or compare different designs on a single project in real time to start to determine where optimization is so valuable and key now. And like, just emphasize Megan's point, or in agreement, like I think that ability to have that reporting so detailed, the level of rigor there is so important. And as we're kind of transitioning into this new future of additional constraints and the complexity of those constraints, this way of thinking really lends itself to providing other constraints and other kinds of optimization that existing tools just don't afford. Or it's kind of Felix brought up earlier, you could do it, but it requires a whole team of people and a lot more time.
Mm-hmm.
Yeah, I agree. I think really what pvDesign has done is created a communication tool between individuals with different backgrounds within the same organization, and then also to be able to communicate to other organizations, really that the user of pvDesign is thinking about and has analyzed these different configurations, and that the results are accurate ones, meaning that the energy yield is integrated. And I've been in the space for over 20 years and sort of been sitting on all sides of the table. And when I think about the sophistication and the maturity of the solar space right now, oftentimes you actually have different developers that may take over a project in different stages. And David, I know you pretty well. I know you've been in this position. I'm sure, Megan, you have as well. You've been in the position where an early stage developer brings you a project and they have done an analysis on one design, and maybe it's a fixed tilt design, and they're showing you the economics, and you're reading through the information memorandum, and in the back of your mind, you're thinking, this is not the best design for this piece of land. However, I'm not 100% sure exactly how much better it could be. And pvDesign, if you're an early stage developer, you can actually show a number of different designs and you can actually talk about it. So as an early stage developer, you may be able to get more money for your project if you're going to sell it. And if you're a late stage developer looking to acquire this project, it will actually help you to understand how to best monetize. So it's just a very convenient tool for utility scale, and it's just a very elegant combination of these different pieces that can really just enable everyone to do their job better, faster, cheaper.
Great. I mean, you can perform better analysis because you have been comparing much more the configurations of your plant, and therefore you can, of course, have the best results and the lower LCOE. With regard to you were mentioning, Greg, that we were talking about utility scale. We were talking yesterday with Megan as well, that you have been, well, Megan in particular, you have been working in projects with a smaller size, and you have covered like all the sizes. Tell us more about your experience in projects with less, I don't know, with less megawatts and more megawatts.
Yeah, I've had experience in developing projects from the 1 to 2 megawatt clear up over 500 megawatt size range, and I've used PVDesign for those projects, the East Coast, the West Coast, down in Texas, and so have had an ability to work across many sizes and landscapes. And I've seen that the flexibility, the accuracy of the software has been consistently reliable from those small projects to large projects. But why I think that's most important is it's historically on those smaller scale projects, it's been a different use case. It's been a lot of times, set of developers and constructors. And so the need for, I'd say, sophistication in energy modeling has not been as necessary as I think it's now becoming. So as utilities are looking more at these community solar gardens, there is a need to have a better energy yield analysis using PVDesign versus PV watts and what's been done historically. And so this is definitely a tool that can be used for clients that are focusing in on those smaller projects.
Nice. Greg, attorney, going back to what we have been working until now, like the typical tools, PVCS, etc. What's your opinion on using other tools when it comes to financial stakeholders? How can we tell them, hey, we have a different product there? What's your opinion there?
Yeah, as Dave and I mentioned in a white paper that we wrote on this topic for RatedPower, which I believe is going to be available to the audience members at the end of the session, there really is, there are certain things about a site that are specific to the site, and those are really inputs into an energy yield model. But there are a lot of portions of the calculations for energy yield that are universal, and we understand them. So one of those things, for example, is we know for a given longitude and latitude exactly where the sun is at any time of day. So in some respects, the engine that calculates energy yield it's very well known what the formulas are, for example, to input into the position of the sun relative to energy yield. So that's something that is common among all of the software that uses that calculates energy yield. So what remains sort of a bigger challenge is what are the inputs to the models, which are site specific, but those challenges are the same for any kind of software. So whether you're using PVsyst or PVDesign or any of those other software systems, you still are going to have a challenge with soiling, with other inputs that are related to that specific site. So in my opinion, in order to do a robust analysis and in order for bankers and investors to really understand what's going on at that site, rather than having a black box where you put in inputs and you get some number, it's much, much better to have a continuum of related data in the same software package. And we've talked about this, Felix. We're sort of at the very beginning in some respects of really taking the power of that integrated data and comparing it forensically to systems that have already gone up. And we've started talking to some independent engineers about that. We've been talking to some banks about that, because there may be correlations that are going to be helpful, that are really have been undiscovered or really have been underweighted in terms of the parameter and the yield over time. So and it's really companies like pvDesign and the thought leaders at RatedPower that are going to help move the industry forward. And I think that's really exciting, and it's work that we need to do as more capital, even more and more capital flows into the space. If we're going to be asking government agencies and investors to be putting in billions and soon trillions of dollars into the space, we owe it to them and to the people who are the taxpayers and the citizens to be really sure, as sure as we can, that we're getting these numbers right.
For sure. So I don't know if well, we're running out of time, so thanks to the three of you for your insights. I just want to have some time for Q&A. It is clear to me that we need, or from their discussion, we need embedded tools like PVDesign to enable in great measure the analysis and unraveling the most optimal configurations of PV plants, and of course the analysis of the performance of a PV plant with a greater data set, including design parameters, lead to better decisions, and subsequent stages like O&M or forensic stages are much more accurate, right? Amazing discussion. Now, I have some questions here. I'm gonna stop presenting now, because otherwise I want to see your faces better. Okay, great. Many of the questions are relating to PVDesign itself and regarding the involvement of Felix, but if you want to jump in and share your opinion as well, Dave, Craig, and Megan, let me know. First, I have one here saying, if we calculate IAM losses, and if we do so, how?
Right. We do have an IAM model in PVDesign. There are actually 4 models. So if the PAN file has the IAM profile, we use that. And we use that for the front face, and for the back face, it can be used as well if you choose so. And you also have another 3 models, which are the Ashrae model and 2 airglass models. And so it's taken into account in every Ryan's calculation, front face and back face.
Great. Then we have here a question regarding PVDesign, if it can generate a P90 and P95 scenarios.
Not yet. We haven't looked into it for a while, but we still haven't gotten around to doing it. Right now, you will have to change the meteorological file for that. So the TMY, you can adjust that and use that to simulate using a different P whatever value.
Great. Then, well, good one. Well, I know the answer, sorry. Does PVDesign have the ability to model a single project with multiple orientations or tilt angles?
You can model different, you can make different simulations with those different tilt angles and compare the results. Within a single simulation though, the entire PV plant has to have the same tilt angle right now. Again, that's something that we want to change in the future, but that's a bit of a hard development. So we are definitely, we have been looking into it for a while, but we still haven't gotten around to actually releasing the feature.
And can pvDesign take account trees or other shading objects?
Not today. So like I said earlier, the entire energy yield calculation model calculates the shades in a 2D flat terrain mode. So there is no, you can't include the trees or the shape of the terrain. That's so the development to do that. That's what the 3D shading feature, right? And it's something that we want to start developing this year, hopefully. But I really can't say when it's going to be available. It's logically it's going to be a hard development for us, as the computation time requirements are huge. So it's something that we need to look into very carefully. Like I said, like if you think about it, right, PVDesign, the whole value proposition, if you will, is that it's really fast and it's really easy to use, right? If we include a calculation which takes hours to complete, that kind of breaks that model. So it's something that we need to do very carefully, and we are looking into ways to do it in the proper way.
We're going to do it. Then a question with regard to bifacials. I understand bifacial relies heavily on albedo site conditions, right? Is it possible to carry out the economics of bifacial incremental capex yield for different albedo outcomes?
You can choose your different albedo values. You have two options. You can either use the default options that PVDesign gives you, and we have satellite data in one of the sources, and it comes in monthly resolution, so it's great to see the effects of seasonality, like rains or even snowfall. And you also can create your own data. Then you can run as many simulations as you want, changing these values. And if you were to include the costs in the simulation, you can then compare the LCOE and all of that really easily.
And with regard to the meteo or topographic sources, which ones are available in PVDesign right now?
So for topography, by default, we include Google Earth elevation. So you have that for every single site you upload, you will have that. So it's a low accuracy source, let's be clear about that, but it's usually enough to at least do a slope analysis and to have a look at if there are very restrictive areas within your PV plant. You can do that automatically today with the topography analysis tool. In terms of meteorological data, by default, you will have PVGIS if it's available in your site, but I mean, most of the world is included. And also for every site, NASA Power and NASA SSE. So there is a difference between the three. From PVGIS, we get the TMY, so hourly format, 8,760 values, right? And we use them as we get them for the energy yield calculation model. For the other two NASA sources, we get monthly irradiation, and we have to generate the hourly values using a stochastic generator, like Metanorm or any other of the options which are out there.
So we have plenty of options. One more software development question regarding programming. Does PVDesign have a programming environment, Python or others, that modelers can use to set up a custom runs?
Not today. That's an interesting proposition. We have received, also we have been asked many times about the possibility to have an API, but it's not something that is in the works right now.
Great. I think that there are some questions that are repeated, so I think that most of them. Oh yeah. Well, another with regard to the albedo, we would be able to input monthly albedo values for site, even available in TMY file.
Sorry, let me read that again. Yeah, exactly. Yes, they are separated. The TMY is independent from the albedo data, so you can mix and match different TMYs with different albedo definitions, and it's fine.
Mm. And how is PVdesign calculation considering clipping losses for high DC and AC ratio? The simulations type step or hourly or sub-hourly?
So the simulations are hourly. We can't yet simulate in sub-hourly steps. It's something that we will do in the future, probably sooner than later, I would say. But because of the batteries, we have been getting a lot of interest in battery storage, and it seems like it's a fundamental feature if you want to simulate that. Regarding how the clipping losses are considered, so we take into account the power of the inverter, right? When the DC array exceeds the power of the inverter, that gets clipped and gets added as an overpower loss, and you find that in the energy report in PDF. It's actually our modelization differs a bit from PVsyst in that we run the full 25 years of the simulation, or whatever value you set, right? You can do up to 50. We run each year separately. And so it becomes interesting because when you consider the degradation of the module and how that affects the DC array power, right? So as the years go by, the DC array power goes down. And so the losses also go down. The clipping losses go down as the years go by. And you can see that in the PVdesign analysis. And you can actually, we have a document which is the energy Excel file, and there we have the percentage losses for each year, and you can see the clipping losses go down as the years go by.
Great. Well, unfortunately, we reached the end of our session. I wanted to thank first all the audience that came here and listened to us, and of course to Greg, Megan, Dave, and Felix. We will be happy to send you the questions that have been raising throughout the session by email. And if you want to know more about RatedPower product offering, let me share my screen. Yes, we got you covered. And don't hesitate to visit our website and request for a demonstration of PVdesign. Have a good day and see you soon, and stay safe.
Thank you so much.
Thanks, everybody.
Thank you.
Bye.
Bye-bye.